In 2135, a potentially hazardous asteroid called Bennu will make a close flyby of Earth. During this encounter, our planet's gravity will tweak Bennu's path, making it a challenge to calculate its future trajectory and the odds of a potential impact late in the 22nd century. Why is this hard to determine? Well, we know how gravity works, but there are still uncertainties in Bennu's trajectory that will be magnified by the close encounter. In addition to gravity, asteroids can be pushed around by non-gravitational forces, like the Yarkovsky effect. When sunlight strikes a rotating asteroid, the day side heats up. As the asteroid turns, the night side cools down and releases the heat. This exerts a small thrust on the asteroid, which can change its direction over time. The Yarkovsky effect is challenging to model, but it can make a big difference in determining where asteroids end up. Because we don't know exactly how the Yarkovsky effect will perturb Bennu's orbit, we have limited knowledge of where Bennu will be as it approaches Earth in 2135. Scientists thus have to consider a range of possible trajectories, depending on how strongly the Yarkovsky effect is pushing on Bennu. A few of these trajectories line up with regions of space called gravitational keyholes. If Bennu were to pass through a keyhole, Earth's gravity would bend its path in just the right way to cause an impact on a subsequent orbit late in the 22nd century. The odds of this actually happening are quite low, but scientists want to know as much as possible. That's one reason why NASA sent the OSIRIS-REx spacecraft to study Bennu from 2018 to 2021. OSIRIS-REx greatly improved our knowledge of Bennu's position, density, thermal inertia, and other properties that can influence how its orbit will evolve over time. The new data allowed scientists to significantly reduce uncertainties in Bennu's predicted orbit, ruling out a number of keyholes for the 2135 flyby and eliminating several future impact scenarios. While Bennu remains a hazardous asteroid, we can now make better models of its orbital evolution thanks to OSIRIS-REx. This will allow us, and our descendants, to better calculate Bennu's risk in the decades and centuries to come.